Hello everyone, John DFA here. And a quick disclaimer before the video starts. My YouTube username may be John Teacher, but I'm not a real teacher. I'm just a student of computer science. Regardless, I just want to let you know that if I do make any mistakes in this video, please let me know in the comments and I'll get it addressed as soon as possible. The goal of this video is to help you guys learn, and I try my hardest to make sure that the problems are correct beforehand. But yeah, if I make any mistakes, let me know. Without further ado, we'll start with the first problem. So today's topic is deterministic finite state automata. And this, in the top middle right here, is basically the alphabet that we'll be working with. That's what this symbol means when I use it, is the alphabet. And then it consists of zeros and ones, just basically any random assortment of binary string is in the universe that we'll be working in, and that's what the little star here means too. But yeah, so to start, we're going to think of a DFA with a language that accepts nothing. Accepts nothing. So take a moment, think about it. What could possibly be the language of a DFA that accepts nothing? And going forward, just with any of these problems, take a moment, pause. I encourage you to think about the problem before watching me do it, because regardless of whether you think about it or not, when you write something down, you really find out the mistakes that you make rather than just watching me do it. But yeah, I hope you thought about it. So as always, we're going to start with a start state, Q0. And usually, typically when we write DFAs, we have an accepting state as shown by the double circle. Let's say Q1, and if I transitioned 1 onto it, so if a string was just 1, it would move, hold up, it would move like this, boop, and then be accepted. But obviously we don't want any assortment of strings to be accepted. So we will leave it like this, and that is our answer. All right, let's move on to number 2. What the language of the DFA is that it accepts all strings in our alphabet. Accepts all strings. Sorry for the handwriting. I'm a little new to the iPad. But yeah, so any assortment of binary strings. Feel free to pause the video. All right, and we will start. Start state of Q0 again. And let's think about this. We want to accept all strings, so we'll make it an accept state. But there's no transitions. So sure, it'll accept nothing, but what if it's 1, 0? Then we need to transition. So we put a self loop of 0, comma 1. And what do I mean by this comma? It's basically the same thing as saying if I did a self loop of 1 and a self loop of 0, and then I accepted that. But, I use this comma right here to save time. So that's what the comma means if you don't know. But yeah, let's get into problem 3. Problem 3, the language, and I'm going to write it in set builder notation this time. Oops, sorry. Write it in set builder notation where we have a string x that is an element of our alphabet, such that, and if you don't know, such that is what this bar typically means. I know some other people tend to use colons. Feel free to use whatever you like. But yeah, we're thinking of strings that accept even length. So x, the cardinality of x, modulus 2, equals 0. Equals 0. But yeah, if you're not familiar, let's say I had a string x and it equals 1, 1, 1. Then the cardinality is just the length of the string. So yeah, take a moment, pause, and then come back to me with what you think. All right, let's work through it. Accept strings of an even length. So we'll start with our start state. We're going to need another state, okay? And working forward, usually when you work with things of modulus 2, modulus 3, modulus 4, you usually need 2, 3, or 4 states based on how many modulus there are. Not always, but that's usually typically how I like to start them with. So I don't know if there's an easy way to explain this, but we're going to watch and then do 0, 1, 0, 1. And let's start throwing in some strings. So, example, well, what about the string 0, 0 or 1, 0 or 1 or 1, 1, 0? Let's trace it out. So to start, we're going to do 0, 0, 0, 0. Okay, the even string ended in Q1. And then, start with 1, 0, 1, 0, ends right here. Okay, what about 1? Ends in Q1. And I think you're probably starting to get the point here. 1, 1, 0 ends there. So our accept state is this. And sorry about the discussions. I'm getting new to teaching. So hopefully I get a little better at it. But the goal of that exercise was just to make sure we chose the right accept state. Sometimes it helps to trace through things and find out mistakes and draw examples. At least it works for me. But yeah, if you have extra time, it's really good for exams too, to always walk through it. So next, we're going to find the language of x. That's an element. 0, comma 1, star. I did draw a star on the other one. Yes, correct. And then now we're going to look at the language of the strings with an even number of ones. So x to the 1 modulus 2 equals 0. And this 1 means the count of the cardinality of 1s in the x. So if I say x to the 1, or no, I don't want it to do that. Sorry. If x equals 1, 1, 0, and we have an x cardinality of 1, then that would be 2. Then that would be 2 because there's 2 1s in this x. If I say x equals 0, 1, 0, 0, and x cardinality of 0, then that would be 3 because there are 3 zeros. All right. So now that we got the examples running through in our head, let's draw a similar DFA to the one that we drew above. All right. So start state of Q0, and then have Q1, then boom, boom, make it our accept state, and then just have, what are we looking for? Even number of ones. 1, 1. All right. Sweet. And that is our answer. Or is it our answer? Let's think about this. Let's put in the string 1. Just trace it through. 1. Okay, not accepted. Good. That's what we're looking for. What about 1, 1, 1, 1? Okay. 1, 1, 1, 1. All right, that's accepted as well. But what do we do if we have a 0, 1? So we got to think about 0, 2. But we're looking for even number of ones. So the numbers of zeros shouldn't affect where our state goes. So what an idea of what we could do is put a self loop of 0 on this. Now let's work through some examples. 0, 1, does that have an even number of ones? No. So it shouldn't accept. Ready? 0, 1. All right, looking good, looking good. Next, we're going to look at the string 0, 1, 0, 1, 0. Just trace it through. 0, 1, 0, 1, and then we have a 0. All right. And you can keep going through examples, obviously, to ensure that it works and double check my work. But that is a DFA that accepts an even number of ones. All right. And as with any video, the longer you watch, the more difficult that the problems are. And additional parts to the videos might even go into varying difficulties too. This will be part 1 to the DFAs. So yeah, if you need more practice, you could always read books online. You could always practice your notes in class, or watch a couple extra of my videos. You know, it's always nice. Support the channel. But yeah, so the next one is going to be the language of X. Element of 0, 1 star, because it contains any binary string such that it accepts strings containing the substring 0, 1, 0. X contains the substring string, and I'm running out of room here, sorry, 101. All right, so we're looking for anything that contains this substring. All right, that's new. Well, how are we going to do this? The way that I typically like to think about it is just without making all the extra states. Let's just make enough so that we can get to the accept state with 0, 1, 0. I know I explained that kind of bad, so let me show you. Start state of Q0, Q1, then Q2, and then Q3. But what do we make 4 states? Okay, if this string, if the substring is length 3, then not including the start state, I want you to make 3 extra states, okay? And then go like this. Or, oops, sorry, that was the eraser. 0, 1, 0. Okay, those are a little big. Let me draw them a little smaller. 0, 1, 0. All right, so our accept state then, oh God, Q3 is looking a little rough over here, but despite my amazing handwriting over here, the accept state is going to be Q3 in this case, right? So if we have a string, which we'll do example, oh God, the handwriting is decaying. Example 0, 1, 0, and we trace it out, then it would follow like this 0, 1, 0, and then it accepts, but we have one issue. What if it's not 0, 1, 0? What if it's 1, 0, 1, 0? So that's the case we have to think about. So the next step is we're going to have to think about because in a DFA, we need all the possible transitions to be defined for per character. So if our alphabet is 0, 1, all right, we're going to need to define a 1 and a 0 transition for every state. So a 0 is obviously going to like travel along the path. We know that. But what do we do with a 1? Well, if we see a 1, we just self loop until we see a 0. Does that sound fair? If we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then 0, 1, 0, well, then we would go 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0. Okay, so that covers that case. So now we have the zeros and ones defined there. Let's think about it. So we follow this magical journey. Let's say we have a 0. But what if we see another 0 right here? Well, I guess we could go back here, right? Not exactly. What about the case 0, 0, 1, 0? That contains our substring, right? But if we were following it down our path, we would get 0, 0, 1, 0. And that's not an accept state. So that's a problem. We need to think about this. So instead of going there, we can make a self loop on 0 here. Does that make sense? Because if we have 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 0, we still have this substring here. I'll leave that in there. All right, so now we're following along our path. We got Q0, we got Q1. Okay, start thinking about what we do at Q2. So Q2 has this 0 transition right here. All right, but what would we do on a 1? 0, 1, 1, 0? We got to think about this. If we see a 1, 1, then that just breaks it. And we essentially have to start from the beginning, unfortunately. And let's work through 2 examples to make sure that it's good. So through the first one, 0, 1, 1, 0. And then actually, what I will do is I will tack on the correct substring at the end to make sure we are tracing it right. 1, 0. All right, so we're looking for that. Let's trace through it. 0, 1, 1, 0, 1, 0. All right, looking good. We could do one more example to make sure. What would I look for? 1, 1, 1, 0, 0, 1, 1, I don't know, 0, just to make sure it doesn't accept. Let's try that. 1, 1, 1, 0, 0. Oh shoot, did I already? Yeah, I already did the other 0. Sorry. 1, 1, 0. Doesn't accept because it doesn't have the substring. Good. And all right. Are we good? Not quite. Forgot about Q3. And so before that, let's think about it. If your substring 0, 1, and it has 1, 1, 1, 0, 0, 0, we have the substring, but we obviously still want to accept. So, but at this point, at Q3's point, we know we have the substring. We know we want to accept. So we could just allow anything after, essentially. So put a self loop of 0, comma 1. Okay, I gotta probably write that better so you don't think it's 3 ones. 0, comma 1. All right. So, and I'm gonna box it in to show you guys what my DFA is because there's a lot of writing on the board right now. But what I like to do now is I know that there's 2 characters in our alphabet, right? And so we need 2 transitions coming out of every state because, we don't have epsilon transitions or anything. So let's verify this. We have 1, 2, 3, 4 ones. And then we have 1, 2, 3, 4 zeros. That's a good way to verify it. However, I wouldn't necessarily recommend this way. Well, okay, also this, we have 4 states, we have 8 transitions, we should be good. The reason why I don't recommend verifying this way is because say you make the accident, I don't know, you make a 1 transition to here, okay? And let's say we didn't have a 1 here, and then you count 8. That's why I don't recommend looking at it that way. Instead, what I'd recommend a way to verify is to do this. Okay, Q0, I need 2 states. 1 state, 2 states. 0, 1. All right, Q0 is good. All right, Q1, 1, 0. All right, Q1 is good. Okay. Q2, 0, 1. Q2 is good. Oh, wait. Forgot to draw that in. All right, Q3, 0, 1. Q3 is good. That's typically how I would like to verify it, but just another way to improve checking to make sure you have everything that you need. And reminder, that is a problem with the DFAs that you do need to pay attention to your transitions. But yeah, let's now start moving on to, I do not want us to do that example yet. Sorry about this. Let me think for a moment. I do not have it written down. Very unfortunate. But let's think about the language of X. That is an element 0, 1 star, which is just any binary string, such that the cardinality of X modulus 3 equals 2. So let's think what I mean by that. This string has a length of 3, okay? So let's say X has this. X cardinality modulus 3 would equal 0, right? But we don't want that. We want the remainder to be 2. So 0, 1, 1, 0, 1 has 3, then 2. So our set of X, let me use a different variable, Y. Y modulus 3 equals 2. So basically we want divided by 3, we have a remainder of 2. That's what we're looking for. There's probably a better way to describe it, but that's what we'll work with. And if you remember my tip from before, we're going to need 3 states, or at least the way I'm solving it is going to use 3 states. I'm sure you could use more if you want, but this is how I would recommend. Because it's modulus 3, I recommend using 3 states. In a simple modulus equation too. Sometimes you might have an equation that has a complex modulus, then this rule wouldn't apply. But if it's just modulus, then I believe this rule will apply. So yeah, as always, we're going to start with our start state Q0, then have Q1, and then have Q2. All right. And then we're going to have our transitions like this. But wait, does that make sense? Well, if you have some number, some number, some number, some number, That's 4. It's not what we're looking for. No pun intended. So we don't need the double transition here. But instead, we could do a transition like this. And as always, pay attention. This is any character, so we will need 0, 1 transitions along the line. All right, now we need to figure out our accept state. So let's start with 0, 1, 0. And let's trace it out. 0, 1, 0. Oh, shoot, I apologize. That is not the string we're looking for. 0, 1, 1, 0, 1. So let's trace that out. 0, 1, 0, or 1, 0, 1. A lot of zeros and ones we're working with. Okay, so this guy should be our accept state, but as always, we should verify. Let's do 1, 1 and try that. So we got 1, 1. There we have it. And that is our accept state. As always, you can work through more examples, but I do believe that this is the complete DFA. For the language that's divisible by 3, it has a remainder of 2. Or not divisible by 3. Divided by 3 has a remainder of 2. Misspoke a little there. All right. Now, for our challenge problem, and our last problem, we're going to do a nasty substring one. So, the language of x is an element of 0, 1 star. And where x has the substring, oh god, my handwriting, 0, 1, 1, 0, 0, 1. Okay, that's a beefy boy. But, and I'm going to write smaller this time. I apologize because we're going to need a little more room on the iPad. And it's going to get messy if I have to write it off screen like this. So, but yeah. Remember my advice before. When you have a substring problem, let's go to it. Where is it? It contains substring 0, 1, 0. Then we make 3 additional states. Oops, I think I subtracted our bar. So we have 1, 2, 3, 4, 5, 6. So we're going to need 6 additional states other than the start state. So Q0, Q1, Q2, Q3, Q4, Q5, and I have short-term memory loss, so 1, 2, 3, 4, 5, 6. That's a joke, by the way. I just forgot the count. All right, believe that's right. And then this will be our accept state. And, you know, I already know we don't care about anything after once we have the substring, so we can make that 0 and 1. But yeah, let's make the transitions. So on a 0, on a 1, on a 1, on a 0, on a 0. Oh god, I murdered that 0. I apologize. 0, 0, and 1. So 0, 1, 1, 0, 0, 1. Okay, that, god, the ones. Okay. Yeah, first time on an iPad. Hope we're doing good. Okay. So, at the start, we see a 0, we move onward. If we don't see a 0, we should probably keep looping on the ones. Okay. We see a 0, and then after that, we transition on a 1. So what would we do on a 0 there? Well, we don't have to, we spoke about this last time. We don't have to take a transition 0 back because that would be incorrect in doing so. So we do self loop. I should probably complete that self loop a little more. 0. All right. And now we check in the transition 1. What do we do on a 0 here? Well, if we have a substring 0, 1, 0, 1, and we don't get those 2 ones that we want connected, like this, or like this, we want the double 1. Is there a way I can? Oh, learn something new. Okay, sweet. But yeah, we don't want we need the double 1. If we don't get the double 1, then unfortunately, we're going to have to go back to here. And why not here? Well, because we've already seen a 0. So that's why we take it back to Q1 instead. But yeah, all right, so we take a 1. Now we're looking for a 0. If we see a 1, could we go back to here? Not necessarily, because we need a 0 before that 1. And if we had 0, 1, 1, 1, then this would be part of the substring. This would be an element of our string, even though it doesn't contain this substring, if we put the 1 all the way, the 1 to Q2. So, can't be doing that. We're unfortunately going to have to take it home. Try again. All right. So now we take the transition 0, and we're looking for another 0. But, as always, what if we see a 1? Well, we take it all the way back. Is that right? Take 5 seconds. Think about it. Is that right? Now, why isn't that right? Well, look. We take a 0. Okay, we see a 0. Then we see a 1. Let's say we see a 1 here. Interesting. We see a 0. Oh no, that was the eraser. I'm not sure how that, what I'm clicking on my Apple Pen that does that. I'll get that figured out by the next video, hopefully. But we see a 0, and then we see a 1 here. But that's what we're seeing here. We see a 0, and then we see a 1. Interesting. So we can take this guy. All right. Then we see another 0. We're almost at the home finish, but we see another 0 here. What do we do in this situation? We got 2 zeros lining up. Then we see 3 zeros, so we can't go anywhere here because there's no 3 zeros in our substring. We have no 3-0 combination to fall back to. When we see a 0 here, we don't want to repeat that 0. So the only logical place to put it would be here. Does that make sense? Because we're seeing a 0 on the transition here, we don't have to start back to the start because we're seeing 1, 0 effectively. And that is good. Then we take the 1 transition, and then we're accepted. So, as always, I'd like to do a quick check to make sure we have it. 1, 0, Q0 is good. Q0 is good. Then we have 0, 1, Q1 is good. And just to clarify if it wasn't before, this is an arrow pointing here. All right, Q2, 1, 0. All right, Q2 is good. Q3, 0, 1. Looking good there. Q4, 0, 1. Looking good there. And then we have Q5, 1, 0. Looking good there. And then we have Q6, 0, 1. Oops. We are looking good there. Perfect. Now, for sanity's sake, let's walk through one incorrect substring and one correct. We could walk through more, and I recommend you to on an exam, just to verify if you have extra time. But, you know, I hope this is correct, but obviously we don't want to spend all day working through extra stuff. 0, 1, 1, 0, 0, 1, 1. This is our substring. Let's verify. We have 1, 1. Then we have 0, 1, 1. 0, 0, 1, 1, 1. Awesome. All right, for our next example, let's make sure we don't have the substring. I don't know, 0, 0, 0, 1, 1. Let's go 000 and then a 1. That's not a, yeah, I'm pretty sure it doesn't have a substring. All right, so 1, 0, 1, 1, 0, 0. We have a 000. Then we have a 1. It ends in Q2. Is Q2 an accept state? No. We should be good. All right. And that is a complete DFA for the language that has the substring 011001. As always, thank you for watching the full video, and I'm happy to see you in the next one. Have a good day.